So, what about this geometry? How will it look on the SAT? I'm glad you asked. It's your girl Tiffany with Tiffany's Tutoring and Consulting LLC, guiding you through these education streets, SAT edition. We're again in good old test 4. Again, it is free from the College Board. All right, so let's look at some geometry problems. Now, it's interesting that the SAT includes some formulas for geometry it at the top of your module sheets, right? So I kind of picked out ones that were relevant to the problems we're doing. Here, the main one that's going to be relevant is it tells you the sum of the measures and degrees of the angles of a triangle is 180. So we're going to use that in this first problem. Right triangles PQR and STU are similar, where P corresponds to S. If the measure of angle Q is 18, what is the measure of angle S? So it kind of gives you a similarity statement, but I still like to write it out just so I'm clear. And then I like to stack my letters. Now I like to stack these for similarity and congruence so that I can see what letters or I'm sorry, what vertex is going to be correspond to another vertex or whatever side is correspond to another side. So I'm going to stack PQR over STU, or I could do it the other way. So when I do that, I see that Q and T are similar or corresponding, R and U are corresponding, and P and S are corresponding. Now, because this is a similar triangle, the angle measure is preserved. This is a dilation. It went from a bigger triangle to a smaller one. Angle measure is preserved in rigid and non-rigid transformations. So I know that if I know the angle measure of P, I'll know S, for example. If I know Q, I'll know T. If I know R, I'll know U. So let's start up with Q and T. Q was 18 degrees. So I know that T has to be 18 degrees. U and R, I can see are 90 degrees based on the marking of the right angle. Now, it said that the total degrees, the sum was 180, which is our total. So I'm going to just subtract 18 and 90 from 180, and that's going to give me 72. So that's going to tell me that angle S and angle P are both 72 degrees because they are corresponding angles of similar triangles. So my answer is B. Now, some of the trick answers is 18 because it gave you Q and T. And if you didn't do your similarity statement, you may kind of get tripped up there. So watch out for that answer of 18. All right, number 20. Point O is the center of a circle. So we're going to draw a center here to our circle. And it says the measure of arc RS is 100 degrees. So we're going to do arc RS. Okay. So if I make an actual angle from arc RS, this is what I get. Let me make that a little bit better. That was a little janky. All right. Thank y'all so much for working with me. Here we go. That is 100 degrees for that arc. Because this is a central angle, and we know that it's a central angle because the vertex is the center of the circle, the central angle is equal to the associated arc that it makes on the circle. So again, central angles are equal to the associated arcs. So that means that the measure of angle ROS has to be 100 degrees. Pretty straightforward there. Number 17, for a certain rectangular region, the ratio of its length to its width is 35 to 10. If the width of the rectangular region increases by 7 units, how must the length change to maintain this ratio? Great question. So what I'm going to do here is draw a little picture. I love to draw pictures, right, to give me a visual of what I need to know. So my length is, I'm sorry, it's 35. My width is 10 as far as the ratio. Then it says the width increases by 7. So I'm just going to add 10 plus 7, get me 17. What happens to my length because I want to maintain this ratio? And here's the key, guy: maintain the ratio. Maintain. If I want to maintain this ratio, that means that the rectangles must be similar because in similar figures, the ratio of the sides, the proportion of the sides, the ratio of the sides remains the same. So I'm going to go ahead and do a good old proportion. And I know to do that again, to just slow it down, is I want to maintain the ratio. To maintain the ratio, you have to make the assumption that these were similar figures, and therefore I need to make a proportion, or I can make a proportion to make it a little more simple. So to solve our proportions, we set it up this way. Again, we want to make sure we set up, for example, the length goes with the length or the width goes with the width. You can do it the opposite way around, but you just want to make sure that your um, similar measurements are either across from each other or top and bottom. You don't want them to be diagonal. For example, you wouldn't want X and 17 to be mixed up. All right, so we're going to go ahead and cross multiply to solve this proportion. Again, it doesn't matter which side you put it on, it's the equal sign. When I do that cross multiplication, Then I'm going to go ahead and do inverse operations. 10 and x are being multiplied. The inverse of multiplication is, you got it, division. And I get 59.5. Now, a lot of students may be like, wait a minute, Miss Tiffany, I don't see that answer on here. You don't, because that's not the final answer. They didn't ask you what the new length was. They asked you what had to change to get to that new ratio. So guess what I'm going to do? You guessed it, I'm gonna go ahead and do good old subtraction so that I can get this answer. So I have 24.5 units. Now, C and D are obviously wrong based on our answer. And then we know it's an increase because it went from a small rectangle to a larger rectangle. Be careful with the decrease. That's a little bit of a trick there. And be careful of the seven. You could think, oh, it increased by seven. So that means that the length increased by seven. Well, the length and the width are different numbers. And to maintain this ratio, we want to make sure that there was a different number. You could even put in seven and you would see that those ratios do not equal each other. All right, hopefully this helps. This is part one. Stay tuned for part two and three of this geometry on this SAT. All right, y'all. Peace.